Okay, I sent out the questions for the free response. They're from exams 2 and 4. The projectile motion question, I said there are 8 questions. That means there are 4 questions each with 2 parts each. So for example, on this question 1, I don't ask this question. I just ask B or C. I think actually I asked for the horizontal range instead of the vertical range. I don't remember that exactly. I'm pretty sure it was horizontal, but you should be able to do both. So let's do this. This is a problem where I have a ball that goes up and comes back down again, and I want to know the vertical range in this case, and then the speed of the ball. I always like to just first find the adjusted. I just like to first find the V0x and V0y. I usually do that first. It's just, I don't know, 22 cosine 60. And then V0y, it's equal to 11. And then V0y is 22 sine of 60. That's equal to 19. And then you can use those as you move through. The next part, starting, I'm just going to start with part B, since part A is not on the exam. For part B, first you want to find out what is the time at the top of the trajectory. I know at the top of the trajectory that Vy is equal to 0, so I can use that fact. Vy at the top is equal to V0y plus Ay t top. That's Vy at the top is 0. That's equal to V0y, which is 19 minus 10 times t top. So that tells me that t top, if I solve that, is equal to 1.9 seconds. Okay? If I want to know the horizontal range, this question is asking for the vertical range, but in your test, I'm pretty sure I asked horizontal. You would say x is equal to V0x times t, and that t that you're going to use is not t top, it's t total, because I want to know the position of it over at this point, and so that's going to be at a time t total is 2 times 1.9, that's 3.8 seconds. All right, so x is going to be equal to 11 meters per second times 3.8 seconds, and that's 42 meters. All right, and then for the second part, what is the speed of the ball at t equal 2.5 seconds? Well, first of all, at t equal 2.5 seconds, I'm somewhere in the second part of the trajectory, and I'm going to have 2 parts to that velocity. I have an x component in that direction, and I have a y component in that direction. The x component, I know Vx is equal to V0x, so that's 11 meters per second. That's because the x velocity does not change in projectile motion because Ax is equal to 0. So Vx remains at 11 meters per second. And then Vy, that's that component of the velocity right there. I can calculate that. That's equal to V0y plus Ayt. That's 19 minus 10 times t, which is 2.5. That's 19 minus 25, or negative 6 meters per second. It does come out negative, as you would expect it to. And then finally, to find the velocity, the magnitude of this velocity, I take the square root of the sum of the squares, 11 plus 6 squared, 11 squared plus 6 squared. Notice here that I didn't leave the negative in. You could leave the negative, but be very careful because when you square that number, the negative goes away. So if you leave the negative, you have to put it in parentheses. Is that clear? I don't want y'all to miss that because you just made a calculator error. That would be half off. Like if you didn't get the right number, here, just leave the negative off. It's not important, right? Because it's a squared number, and so the negative goes away. Anyway, so that's, bless you. That's 11 squared plus 6 squared. Square root of that, I get 12 or 12.5 or 13 meters per second. All right, so that's the first free response question. I'll just change the numbers. I said I don't ask you part A, I just ask parts B and C, and I'm pretty sure I asked for horizontal range. Though vertical range, you should be able to do that too, right? If I'm asking for vertical range, I would just say y is equal to v naught y times t top plus 1/2 ay t top squared. I use t top to find the vertical range because I want to know the position up here. I'm pretty sure I asked horizontal range though. All right, then this next one, I don't ask part A, I just ask part B and C. That is, with no friction, what is the acceleration? And then with friction, what is the acceleration? All right, so first you want to draw your free body diagram. It'll help you to sort of write the equations. I have my normal force here. I'm going to go ahead and resolve my weight vector into its components. That way I don't have to redraw it. I think y'all are probably to the point where you recognize that. So that's FW cosine of 60 and FW sine of 60. All right, what I did there is there's normally a force weight vector there. Since this angle is 30 degrees, the angle between it and the x-axis would be 60 degrees. And so I just find the x and y components. There is another force, the frictional force, but I'll wait to put it on until part C. So let's start with part B. For part B, assume no friction. What is the acceleration of the block? Okay, well that's pretty easy. All I have to do is say that the sum of the forces in the x direction equals max. That's FW cosine 60 minus 160 is equal to the mass times the acceleration. The weight is 15 times 10, or 150. If I solve that for A, I get 150 cosine 60 minus 160 divided by 15. I get minus 5.7. I would take positive as long as you tell me that it's up the inclined plane. So the magnitude and the direction are important there. And also recognize here that I'm taking to the left to be negative and to the right to be positive. Even though this is up the inclined plane, I'm pretty sure I just used this figure again and just changed the numbers. I'm pretty sure that I used that same orientation. All right, and then for part C, it's a little more difficult because you have to find the frictional force. And in order to find the frictional force, you first have to find the normal force. And the normal force is equal to FW sine 60. I know that because this force is equal to opposite that force. Fn minus FW sine 60 equals 0. And FW sine 60, that's 150 sine of 60. That's 130 newtons. Then my frictional force is mu times the normal force. Mu is 0.1 times 130 equals 13 newtons. Just pause right there, okay? So let's step back through what I did on this one first. I want to know the acceleration in the x direction. So I say the sum of the forces in the x is equal to max. The sum of the forces in the x are this force, which is positive, even though it's down the inclined plane. This force is negative, so I add those two together, and I set them equal to ma. That should be max. That's the acceleration in the x direction. And then I solve that for ax, and then that's the answer. Then for this next part, I'm going to do the same thing, except now I'm going to have another force. That is my frictional force. Oh, not in that direction, I'm sorry. My frictional force, which is in that direction. So I have to do the same thing, but in order to do that, I need to know the frictional force. But in order to find the frictional force, I have to find the normal force and then calculate the frictional force, the mu force normal. Now I can go back and do the same thing I did before. That is that the sum of the forces in the x direction equals max. Looks a lot like what we did before. I say FW cosine 60, that's 150 cosine of 60 plus F, which is 13, that's the frictional force, minus 160 equals 15 times AX. And then I solve that for AX. and I get minus 4.8. It should be less than the previous answer, which it is, a little bit less, because you have this frictional forces slowing it down a little bit. So if you get a number that's more than, you've done something wrong. Okay, those are a bit back, and those were both difficult problems. So let me just step through again what we did. If y'all have questions, just stop me. I always like to find the initial components, just v naught x, v naught y, you're going to need them both. And then here I was looking for the horizontal range. You have to find the time at the top, utilizing that fact that Vy at the top is 0. When it goes to the top of the trajectory, it goes to 0. And then you can find that time. And then you want to find the total time, so you just double it because it's symmetrical. And then I can find x is v naught x times t. And I find that's 42. And then in the second part, find the magnitude of the velocity at a particular time. I know the x component, that's just v naught x. Then I have to find the y component at that time, just using that v equals v naught plus at to find the y component. And then I add those two vectors together, add it saying that I use the the Pythagorean theorem to find the hypotenuse of those two vectors that are at a right angle to one another. And then on this one, draw your free body diagram, draw all your vectors like I've done here. Practice this, because this will be important for the multiple choice part too. You have a 1 or 2 inclined planes on the multiple choice part. Yeah, you have that one where you have to find all the equations, are they correct or incorrect? And then you have another one where it's just like, what is the acceleration of this block? So this comes up again in the multiple choice. Not going to ask you what the normal force is, though you have to find it. But I'm just going to ask parts B and C. If I have no friction, I just say the sum of the forces is equal to max. I add those forces, the vector sum of those forces, and set them equal to max. For the second part, I have to find the normal force, then find the frictional force, then apply Newton's second law. Okay? They're not easy problems. That's why you get them ahead of time. So practice them until you know them well. You will have projectile motion in the multiple choice as well. It's one of those where it shoots out from a horizontal, you know what I'm talking about, instead of going like this. All right, you want to do the other two free response? Is this helpful to do the free response? Y'all just did this, so hopefully this is a little fresher. These are easier problems, I think. You're going to have number 2 and 4, isn't that what I said? Yeah, these two questions. They won't be spheres, they will be flywheels, I think. I'm pretty sure they're flywheels. Yeah, flywheel. A flywheel is a disc, which is, what shape do you use for a disc? Cylinder, right. So I won't tell you that in the problem, but you'll need to know. I'll tell you that a flywheel is a disc, but you need to understand that a disc is really just a flat cylinder. All right, so here it was a solid sphere and a hollow sphere. I'm going to go ahead and find their moments of inertia. The moment of inertia for a solid sphere solid sphere is 2/5 mr squared. That's on your equation sheet. That's 2/5 of the mass, which is 10 times 3 squared. 4 times 9, that's 36. And then I of the hollow sphere is 2/3 mr squared. I think I'm doing this right. That's 2/3 of 10 times 3 squared. Dimensions are the same. That's 20. That's equal to 60. So those are the two moments of inertia. The first part is just what is the angular momentum of the solid sphere, it has this moment of inertia, and that is a speed of 3 radians per second. And so to find the angular momentum, it is L equals I omega. That's 36 times 3. That's equal to 108. Oh, what's that? Kilogram meters squared per second. And then in the second part, these two spheres come together and they begin to spin at the same rate. Your problem will be exactly the same, except they'll be disk. One of them will be spinning, the other one won't. They'll engage, so you'll work it in the same way. For the second part, that 108 kilogram meters squared per second of angular momentum is going to remain constant, but the moment of inertia is going to increase. So I say 36 plus 60. That represents those two objects coming together now, and they're spinning together, and they will spin together with the same omega. I don't remember what that omega was. Let's see, 108 divided by 96. 1.1, right. Radians per second. You did pretty well on that on the exam overall. Overall, the free response was quite good on the exam. I was very pleased with you. And then this one, I think this one's relatively straightforward too. First, which is bigger? You'll have that question. You just look at the levels. The one that's closest to the lower level is right here, is argon. So the answer is A, argon, because the level is lower on that side. Or something like that. I don't need a paragraph, just a few words. And then the pressure of the argon gas for part B, I would say that the pressure is equal to P naught plus rho times G times H. P naught is the pressure that is up here. That's P naught. It is an atmosphere. And so 1 atmosphere is 1 times 10 to the 5th pascals. That conversion factor is on your equation sheet. 1 atmosphere is 1 times 10 to the 5th. Plus the density of mercury is 13,600. I think you have mercury in yours. Mercury is pretty common in manometers. Times 10 times H. This was a common mistake. Not many people made it, but a few of you, even like some of my really good students, made it, that you didn't convert this properly. It's in millimeters, so you're going to move that over 3 spaces. So this is just 0.429. Some of you didn't convert it at all, so you got a really huge pressure. And some of you just didn't convert it correctly. You moved it only 1 or 2 spaces. And then that worked out to be 158? I think it was 158. 1,000 pascals. Or 1.6 atmospheres will be correct. Or 1.6 times 10 to the 5th, or something along those lines. I think it should be 1.6, actually, if you're following. No, it looks like I should have 3 significant figures, so 1.58. But I didn't count off for sig figs. All right. Are there those are all the free response. Any questions about that? You probably haven't started practicing them yet, have you? Yeah. No shame if you haven't. It's okay. But work through them a couple of times before you come into the exam, just so they're familiar, especially those from exam 2. All right. Are there particular questions from particular exams? A sig fig? Yeah, you have one of those. I took 10 problems from each exam, but yeah, there was a sig fig problem. It'll be similar to this one, where I have this simple expression, and you have to calculate it with the right sig figs. Follow your order of operations. Anything in parentheses is always first. So I'll start with that addition. Addition isn't always first, but parentheses always are. So that's 7.25 plus 1.3. That is 8.55 or 8.6. Because I just keep I keep the lowest number of decimal places when I'm adding. And then that's divided by 2.22. That must be equal to 3.874. But when I'm dividing or multiplying, I keep the lowest number of sig figs. So I have 2 sig figs right here. So the answer is C, 3.9. Okay? You're going to have an estimation problem. Like see here where I have 2 of these. where there are two estimation problems, you can bet that there's going to be an estimation problem, just one. And it'll be something similar to this, something that's familiar to you, that you have to estimate the mass, area, volume of it. Likewise, with these, see there are two-dimensional analysis. That means that you're also, you can bet that you will have a dimensional analysis problem. It was a little bit different, but still. The trig problems, you're not going to have trig problems because that comes up in the, like this number 7 and 8. You won't have those specifically because they come up in a lot of other problems. So I don't feel a need to assess you on that. Pretty sure there was a standard problem. This is asking for the kilogram, but you need to know also the other standard. So that's one way that I could change this. Instead of asking for the kilogram, I could ask you what is the standard, I don't know, for the meter. For the meter, it would be E, the net constant speed of light. I could also ask you for the standard for the second. You know what the second is? What's that? Yeah, the cesium atom, D, right. So know all three of those standards. It's actually a question very similar to that, but it's pretty sure it's not kilogram. I'm just going to sort of skim through here. Y'all didn't do very well on number 9 on this exam, but I did not put it on the final. Okay, so you can disregard that. You do have 1 or 2 questions having to do with kinematics. Those equations are not on the equation sheet, so I'll just remind you of those. I always like to write them down as I'm working the problems. That is that V equals V naught plus A times T, and X is equal to V naught T plus 1/2 AT squared. Those equations aren't on your equation sheet, but they kind of are too, because the kinematics equations for rotational kinematics are on the equation sheet, and they have the same form as these. It's just, omega and alpha instead of V and A. Let's just do number 11. I just write down what I know. X is equal to 100. T is equal to 10. He continuously accelerates. So I don't know what A is, but I know it has some acceleration. I also know that V naught is equal to 0, that they start at rest. And I want to know what is V. I know V is equal to V naught plus A times T. Oh, but I don't know A, so I'm probably going to need to find it with this other equation. X is equal to V naught T plus 1/2 AT squared. V naught is 0, so that term goes away. And so I get 100 meters equals 1/2 of A times T, which is 10 squared. So A is equal to 2 meters per second squared. And then once I get that, I can plug it in right here and find V. That's 0 plus 2 times 10. That's equal to 20 meters per second. So C is the right answer. You'll have something similar. I think yours was actually a little simpler than that one, a 1-step problem instead of a 2-step problem. But still, you're going to use the same process. I always recommend students write down the equations or write them on your equation sheet. Your equation sheet will be a whole separate page, just like it was on this exam. So I recommend that you just tear it off and put it sort of next to you, so it's always right there in front of you, instead of leaving it stapled. Write down the equations, write down your knowns and your unknowns, and then usually for me that becomes more apparent on how I'm going to approach it, just mathematically, algebraically, how you're going to approach it. All right. Y'all stop me. I'm not saying these are not on the exam. Actually, there is a vector question that's like this on the exam about displacement. Definitely have some graphing questions. So there are, 3, 4, 5 graphing questions where you have to analyze things like this, analyze graphs like this qualitatively, and then also graphing questions like this where you're analyzing them quantitatively. We're actually finding the slope or area of a graph. So that's very important for this exam. In fact, it comes up on exam 1 and exam 2 having to do that. So you'll certainly see several of those. I don't know, let's just practice this. Well, I'll give you a different one because you've seen this one. Let's see, that's X versus T. What if my X versus T looked like that? Well, my x versus t, the slope of this graph represents the value of this graph. So this has a big positive slope right here. That means my velocity should be big and positive, which means that that one and that one are both not options because part A starts with a small negative velocity and B starts with a small positive velocity. But the slope right here is big and positive, like right here. Oh, that gets rid of that one too. Oh, I'm sorry, it doesn't actually. All right, it should go all the way over like that. So this one starts with big and positive. It goes to 0, and then it ends at big and negative, just like that. Okay? Do y'all know what the answer is for the one that's stated? Is it A? Yeah, it starts out small and negative, and then gets big and negative. It starts out small and negative right here, and gets big and negative as you proceed. So definitely see some like that. All right. Particular questions on this stand out to you? You're going to find the slope of a graph. All right, exam 2. Pretty sure I gave you this one. Almost certain. Yeah, I'm certain I would have. Yeah. So you have one like that where you have to calculate the horizontal range. Y'all know how to do that? Let me on this. Y'all holler, okay? You have some, you just have one of those questions. Like I said, you probably have one like this, either this type of motion where it goes like that, or I could ask you for that type of motion to give me the position or the velocity versus time graphs. Have a vector question like number 7 or number 8. You definitely have one like number 9 where you're doing graphical analysis. Any particular questions on this one, y'all? I've already told you you'll have one like number 13. I think you had another one too. Yeah, sort of like number 20. So you have 2 inclined plane problems in the multiple choice. One where you're calculating, very similar to what you had on the free response, and then one where you're just telling me what are the equations there. But they use the same skills. All right. Elevator problem, pretty sure you had one of those. You did not have one like number 18. Y'all didn't do very well on it. I did not include it. Okay, that's exam 2. Any particular questions on that one? There are some difficult questions there. I'm glossing over them. It doesn't mean they're not on the exam. Like number 15 is a difficult question. I think number 16, number 19, those are all difficult questions. If y'all want, I can work through them. 15, sure. There was one very similar to this on the test, actually. It's not just like this, but it's similar. Here, I want it not to move, and in order to make it not move, that means that I have to have a frictional force that is equal to the tension. Like whatever tension I have, my frictional force has to balance that out. And I know that the frictional force is equal to mu times the normal force, and so 20 newtons is equal to mu, which is 0.1 times the normal force. So that means my normal force has to equal to 200 newtons. But look, the mass of this block is only 2 kilograms, which means that the weight of that block is only 20 newtons. Force weight is 20 newtons. I know that I have to have a normal force equal to 200 newtons because that's the normal force that will provide a big enough friction for it not to move. So now I need to know what is that force. I have 20 newtons down, 200 newtons up. That means I need another 180 newtons down. So D is the right answer there. Okay? I think yours was more like why I provide that force, and then you have to tell me the acceleration. I'm pretty sure that's how I did it. But it's a similar, you work through it in a similar way. All right? Particular questions. Probably the hardest exam we've had this semester. Exam 2. So it is equally distributed. So there are 10 questions from each exam. I think there was a gimme question at the end. I think that came out of exam 4. So I think there were 9 questions out of exam 4. Did I have a gimme question on this one? I did, right? Number 12. Huh? Yeah. Okay. All right. Exam 3 then. No free response from exam 3, though number 3 on exam 3 is a lot like the spheres problem that we had on exam 4. That's why I don't do linear momentum on the free response, because we do angular momentum. But, all right. Yes, all these. A lot of y'all missed number 3. I don't know if it was just confusing, but I did not put it on the exam, because y'all did very poorly on that question. I thought it was an easy question, but a lot of people missed it. It was just the wording was wrong. Not wrong, you just, I don't know. Tricky? Is tricky the right word? It's not tricky, is it? Is it?
Is it though?
No, at position C, like if I have a pendulum that's going back and forth, here it stops. So it has potential energy, but no kinetic energy. It only has potential energy. Maybe it's just a little confusing, that question. All right. Spring question on there. Pretty sure there was a question like number 7. I had at least one question for SI units. It might have been work or energy. I don't remember, but do know your SI units. Don't memorize them. Just if I ask you this question, just write down the equation: force times displacement. Force is mass times acceleration times displacement. That's kilogram meters per second squared meters. So it's kilogram meter squared per second squared. So I know I asked an SI unit question, and that's how you approach and just write down the equation. All right. Like I said, 5 and 7. Expect something like that. There will be a conservation of momentum problem, sort of like this one, and an impulse problem, sort of like that one. Yeah, a lot of these we have on it. We can go back. Okay. Any particular questions you want me to work through? Yeah. So number 10 is a conservation of momentum problem. Initially, it's just sitting there. The cannon is sitting on this railroad car, and it has an initial momentum equal to 0. But then, after it shoots a cannon, or shoots a cannonball, that cannonball has a momentum in that direction, and the cannon will have a momentum in that direction. So the initial momentum is 0, and then that's going to equal to the momentum of the cannonball plus the momentum of the cannon. All right, so covered up some of my stuff. Let me see. Remember, P is equal to M times V. So 0 equals the mass of the cannonball is 10 kilograms times its velocity, which is negative 100, plus the mass of the cannon, which is 1,000 kilograms, times its velocity. So that gives me when I solve this, I get 1,000 divided by 1,000, our V is equal to plus 1, or 1 meter per second to the right. Okay? While we're doing it, let's do number 12. I said it's on the exam. When I have this where I'm changing speed like that, that should clue you in that this is an impulse problem. And an impulse problem, that means I'm doing this F equals delta P over delta T. That's on your, y'all had an equation sheet for this, I think, right? Yeah, you did. This is on the equation sheet for chapter 6. I'm looking for the force. So delta P is M delta V over delta T. mv is the momentum. M delta V is the change in momentum. So that's 3 times 14 minus 12 divided by the time, which is 2. That's 3 newtons. It's kind of nice. Like if I see an object change its velocity, it's pretty easy to determine the force that's caused that change in velocity. It's really easy to measure changes in velocity. Hard to measure forces, but easy to measure changes in velocity. All right. All right, this was chapter 7. There were only a few from chapter 7, so you didn't, because this test had 3 chapters, so you have fewer of each chapter on this one. There's some kinematic stuff there that's similar to what we do in chapter 2. All right, and then finally there's exam 4. Moments of inertia, energy, conservation of momentum, torques. There'll be some ranking problems, conservation of angular momentum problems. Pretty sure I gave you one of these where you had a bar, you had to find the net torque acting on it. There was a Archimedes principle. I tried to make it simple, kind of like this one. Now, particular questions, this one is more recent, so I'll spend less time on it. Now, particular questions from this one? Did y'all think this test was easy? Yeah, maybe, yeah. It was a higher average, but still some people didn't do well, so there's no shame in that, but let's regroup, right? We'll regroup and do better on the final. Finals not, yeah, no.
Can you go get 17?
Absolutely. Yeah, so 17 is kind of like the argon problem, but the only difference is that this P naught, which is the pressure in the top of the barometer, is equal to 0. I say that right here, but saying it in words is different from writing out the actual equation. A barometer actually is just like a manometer, except P naught is equal to 0. So normally, I would say P equals P naught plus or minus rho GH, but here this term just goes away, so I don't need to worry about it. P naught is rho, this is water, so rho is 1,000 times 10, which is G, times H, which is what I'm looking for. And then P is 2 atmospheres. So I had to be careful. I have to convert that into pascals. So a couple pitfalls that you could have faced. You could have not known what your P naught was and just not really know what to do with it. But you had to be able to read it, determine that it's a vacuum up here, so the pressure is 0. And then also being aware that you have to change your pressure from atmospheres to pascals. And then once you do that, it becomes relatively easy, and you get that H is equal to 20 meters. It's because it's 2 atmospheres of pressure. That's pretty high pressure. Yeah, that's actually the pressure that you have when you go 60 feet underwater. If any of you are scuba divers, any scuba divers? Yeah, so every 30 feet, every 30 feet you increase an atmosphere of pressure. So after 10 meters, you get an atmosphere. 20 meters, you get another atmosphere. I'm not a diver, but my brother is. He's a commercial diver. All right. Chloe Relly. She was my student. She's in dental school now. I don't know who these other people are. I just made those up. Y'all know Chloe? Anybody know Chloe? She was a DZ. Any DZs? No? She's going to be a orthodontist. All right. Other particular questions from this exam 4? I said it's still 9 or 10 questions from this exam. It's just it's more recent. All right. Is that good? We're good? let's stop this.